Assalamu alaikum everyone. Today we will discuss scalar and vector quantities and the other and few definitions and formulas related to it. So let's get started. The first quantity which we will be discussing is scalar quantity. What are scalar quantities? They are quantities that only have magnitude. What is meant by magnitude? Magnitude is size. While vector quantities are those quantities which have magnitude and direction. They have magnitude and direction both. So these type of quantities that have magnitude and direction both are known as vector quantities. Let's have a look on few examples of scalar and vector quantity that are in our syllabus of O-level physics. So scalar quantities that are in our syllabus of O-level physics are distance, speed, time, energy, mass, temperature. However, vector quantities that are included in our syllabus are displacement, gravitational force, gravitational field, weight, velocity, acceleration, and electric field. Electrical field and momentum. So these are those quantities that are in our syllabus, and you have to memorize these quantities because questions in MCQ or in P2 can come and they can give you a quantity and ask you that identify that whether it is a scalar quantity or is it a vector quantity. MCQs like that this can come in P1 that um, identify scalar quantities. A, acceleration. B, velocity. C, speed. D, momentum. So according to the list, these quantities are given here. You have to identify which one is scalar. The correct option is speed. Speed is the scalar quantity because it only have magnitude. Magnitude means size. However, acceleration, velocity, and momentum are vector quantities and they have magnitude and direction both. I hope you understood that, how questions related to scalar and vector quantities come in examination. The next thing we will be discussing is motion and the terms you need to know in this and the formulas. Speed is distance. What is speed? Speed is the distance traveled per unit time. What is this per unit time? This per unit time means divide sign. You can just put this divide sign when you are writing the formula. So distance traveled divided by time. This is the formula of speed. Using the form I hope you all know the formula of speed, which is speed equals to distance upon time. So you can convert this formula into definition like speed, distance traveled per unit time is speed. This division sign is per unit. So now let's have a look on the definition of velocity. Velocity is change in displacement per unit time. Again, this per unit time means divide. So change in displacement, which is s, and divided by time, and v is for velocity. So this s is change in displacement. Now let me tell you what is displacement. So using my example, I will explain you what is difference between distance and displacement. For example, this is the distance from town A to town B, and it is 5 kilometers. So this is distance, which is 5 kilometers. However, if this distance is changing direction and I'm telling you that from town A to town B, the distance is 5 kilometers, while from town B to town A, again you have to travel distance 5 kilometers. So the direction has been changed, and you are going from town B to town A this time, and then you are coming from town A to town B this time. So 5 kilometers plus 5 kilometers equals to total distance, or you can say displacement, which would be 10 kilometers. However, in displacement, when you add up this distance, this is distance. Total you travel distance from A to B and then from B to A is 10 kilometers. When you talk about displacement, so the displacement at this case, you can say this is case number 1. In case number 1, the displacement is 0. Why? The displacement is 0 because it is starting from A and ending at A again. You go from town A to town B, and you then again come from town B to town A. So the displacement in this case number 1 is 0. And the distance is in total 10 kilometers. From town A to town B, 5 kilometers, then from town B to town A, 5 kilometers. So distance is 10 kilometers. I hope you understood distance and displacement. Now let's have a look on the second definition, which is of velocity. Velocity is the change in displacement per unit time, and the SI unit of velocity is meter per second or kilometer per hour. So you have to have, while doing the questions or in an exam, you have to take care of the SI unit. For example, if the distance is given in kilometers, however, the time is given in minutes, so you have to convert the minutes into hours. And do not forget to write the SI unit after your answer. Because in some cases, in some questions, SI unit is given there, meter per second or kilometer per hour. Like you have to write your answer here, and here it is given meter per second. But sometimes this meter per second isn't given, and you have to write in your answer the unit of the calculation you did. So this was the formula for display for velocity. Now, average speed. The formula to calculate the average speed is total distance upon total time. The next thing we have to discuss is acceleration. What is acceleration? Acceleration is change in velocity, and the formula for acceleration is A equals to delta V divided by T. Now, what is delta V? Delta V is V minus U, final velocity, minus initial velocity. So this gives you the change in velocity actually. Then divided by T. T is time, or sometimes it is like final time minus initial time. But for delta V, you have to write final. This V is final, and this is U is initial velocity. Gives you acceleration. So velocity is change. So acceleration is change in velocity per unit time. This per unit is again division sign. So while remembering the formula, you can easily remember the definition of acceleration, velocity, and speed. Now, what is deceleration? Deceleration is actually nothing new, but it is negative acceleration. So whenever you calculate the deceleration, so no need to put negative sign with your deceleration you found, because deceleration always means negative acceleration. Now let's move towards graph of distance and speed time. Let's move towards distance and speed time graph. So firstly, we will discuss distance time graphs. So let me draw the graph. On y-axis, there is distance. On x-axis, there is time. And distance SI unit is meters. Our time SI unit is seconds. Now, you can see that in this graph, the line is parallel to x-axis. This where the t is plotted, it is x-axis, and where the distance is here, and distance is on y-axis. Now, the line I have drawn using red pen is a line parallel to x-axis. When the line is parallel to x-axis in distance time graph, so the object, so it means that object is at rest. Object is at rest. Line parallel to x-axis in distance time graph means that object is at rest. I hope you understood this case number 1. Let's move towards case number 2. In distance time graph. Case number 2 of distance time graph is again distance is on y-axis, and so in y-axis distance is there, and at x-axis time is there. When the in distance time graph and the line is going straight and it is steep slope, it is making steep slope, so it represents constant speed in distance time graph. Now case number 3. Case number 3 is now the line is going, it's a curve, you can say, and this curve represents that the acceleration isn't constant, means it the curve represents non-uniform acceleration. So non-uniform acceleration means not constant acceleration, and the change in this curve, or you can say the change in the slope, represents acceleration, which is non-uniform. Non-uniform acceleration, and it is represented by change in slope. So here is a tip that you can remember whether the acceleration is uniform or non-uniform by looking at the curve like this. If the curve is like this, so you can say it's making a half smiley face, which means the acceleration is non-uniform and positive acceleration. However, in this curve, you can see that it is making a curve which is making a half sad face, so you can easily represent that it is negative acceleration. However, this upside open one is positive acceleration. So the case 4, this is negative acceleration, which is known as deceleration. Negative acceleration or deceleration. Now let's look at 4 curves that are in our syllabus of speed time graph. So speed time graph. The case number one of speed time graph is when the object is at rest, so the line meets x-axis. So let me draw the line using another color. Let's use orange color to draw the line. For example, the line is here on x-axis. The line meets x-axis like this. So it means, or you can say it represents that speed here, time here. It represents that the object is at rest. When the when the line meets x-axis in speed time graph, it means that the object is at rest. Now case 2. Case 2 of speed time graph is of the constant speed. When the speed is constant, the line is parallel to x-axis. Constant speed. In speed time graph, when the speed is constant, sometimes in P2 it is asked to draw a graph, and the condition is given that which type of graph you have to draw and what if it is constant speed or is it uniform or non-uniform acceleration. So whenever in speed time graph you have to draw a constant speed graph, so it is always a line that is parallel to x-axis, and the you can see the horizontal axis is always x-axis and the vertical axis is y-axis. Time is independent, so it is on x-axis. However, speed is dependent on time and distance, so it is on y-axis. Now let's discuss case 3. Case 3 of distance of speed time graph. So it is of uniform acceleration. You can say uniform acceleration or constant acceleration, but the correct word or the word that gives you more marks is uniform acceleration instead of constant acceleration. Use word uniform acceleration. In speed time graph, a constant line shows you that the acceleration is uniform, means constant. And this is case 4. In case 4, you can see this. It is going, the graph is making a curve. And this curve is opening upwards. When the curve is opening upwards, I told you above, it means that it is acceleration. When it is acceleration and the curve is opening upwards, so it means that the acceleration is non-uniform because it is a curve, it isn't a constant, and there is change in slope. So non-uniform acceleration. And it is positive acceleration. What if the curve is opening downwards like this? So it would be non-uniform deceleration and speed time graph. Okay, I hope you understood these 4 cases of speed time graph and distance time graph, and you should remember these cases or you should memorize them because they usually come in exam in P1 and P2 and they are essential. Now let's move towards how to calculate speed and velocity and acceleration using these graphs. While using these graphs, you can easily calculate these quantities. Let's get started. So calculating speed using distance time graph. What you have to do to calculate speed using speed calculation using distance time graph. In graph, when you have to calculate the speed, you have to calculate the gradient of that graph. So you can simply remember the formula of gradient, and the formula of gradient is y1, y2 minus y1 divided by x2 minus x1. Now, the second one is calculation of acceleration from the gradient of speed time graph. Now, for example, in question, you are given a speed time graph and they are saying that calculate acceleration. Speed time graph is given. So, to calculate acceleration, you have to use the gradient formula once again to calculate acceleration. The gradient formula is y2 minus y1 divided by x2 minus x1. Or simply you can use the acceleration formula and you can use it like that. Consider y2 the final velocity and x1 the initial velocity and x2 the time of the final velocity and x1 is the time of the initial velocity. And when you put these values using from the graph and calculate it using a calculator, so the answer you got is acceleration. I hope you understood it. Now, area under the speed time graph is used to determine the distance traveled for the motion with the constant speed or constant acceleration. For example, this is in speed time graph given to you and they are saying that the speed time and this is the parallel line. What does it means by a parallel line in speed time graph? The parallel line in speed time graph shows you the constant speed as I told you above. The object is moving with constant speed till 10 seconds. And for example, now you have to calculate, the question is asking you to calculate the distance traveled during this 10 seconds. So speed equals to distance divided by time, and it would be distance equals to speed into time. So the distance would be 500. As 50, for example, is speed and the time is 10 seconds, so it would be 500. Or you can say. Now, one more important thing that you should know according to your syllabus is that acceleration of a free fall for an object near to the surface is always constant and is approximate to 9.8. So let me repeat it once again, or let me write it. Acceleration of a free fall near to the surface of the earth. I'm writing the earth in short form E, capital E, is approx constant. So this acceleration when object is falling near to the surface of the earth, so its acceleration is constant and is approx approximately 9.8 meter per second. So this is a statement you should remember according to your O-level syllabus, because questions related to it may come in exam. So I hope you understood what is acceleration, speed, distance time graph, and speed time graph condition that are included in O-level syllabus. You can see the syllabus, and the syllabus code for O-levels physics is 50454. So you can yourself also see the syllabus while searching it on Google, and you can see that I have covered a few components of the part 1, which was related to motion, in which I have covered speed, distance time graphs, speed time graphs, acceleration, velocity, and free fall acceleration with scalar quantities and vector quantities. I hope you understood.